Equilibrium. Aiming from the light dot to the black dot. In the beginning, plenty of light color and only a few black dots. Time go by, more black and more black and more black until it reach equilibrium. They don't change anymore. You will have that much black dot with that much light dot. So they don't change. On the macro point of view, they are constant, unchanged. But when you look onto the molecule, in fact, they are continually changing. But the forward reaction and the reverse reaction happening continually and at the same rate. So you don't see the change. So in chemical equilibrium, it's a dynamic rather than static. So they are continue reacting, forward reaction, reverse reaction happening, but at the same rate. Chemical equilibrium. To represent the chemical equilibrium, you write the reactant change into product, and the product will change back into reactant. Now we say that this is at a equilibrium. Under the Le Chatelier principle, to say, in case if at this equilibrium, I impose a change, I change it by higher concentration of product or reactant, I change on pressure, and I change on temperature. What will happen if I impose a change into this system? The system will react. How would it react? It will react into a direction to minimize this impact, this effect of change. Please understand this concept thoroughly. We base on this concept for the further. We're going to first study the reactant of product, then pressure and temperature one by one. The effect of changing concentration of reactant and product. In this equation, N2O4 gives 2NO2. If you add more NO2, what will happen? The system will re-establish equilibrium by increasing the N2O4 and decreasing NO2. How? They will shift towards the opposite side. You will shift onto the opposite arrow. If you reduce the NO2 or you take away the NO2, what will happen? The system will re-establish itself to reach a new equilibrium by decreasing N2O4 and increasing NO2. How? By shifting the arrow towards that way. Student, you may start to be confusing. Which way should it shift? Which way should it shift? Should it shift to the left or shift to the right? Now I give you a hint. Here's a picture on the corner. Does this look a bit like a hat Now you see the reactant and the product. Reactant. If you put in more reactant, you add more reactant, equilibrium will shift forward. Equilibrium will shift forward. But if you remove the reactant, you take away the reactant, equilibrium will shift in reverse. Will shift in reverse. Product. If you add more product into the system, the equilibrium arrow will shift reverse. It will shift reverse. But if you take away the product, you removing the product, equilibrium will shift forward to give you more product. And now let's do the exercise. First question. Increase SO2. What happened? So, according to that hat rule, it will shift which way? Next question. Increase H2. Decrease H2. Which way? Next question. Increase HI. Which way? Next question. Decrease NO. Which way? Next question. Decrease CO2. Which way? Increase Cl. Which way? Student, please keep in mind the head rule that we just learned to do this concentration equilibrium. The effect of changing in pressure. When high pressure, you favor the small number. On low pressure, you favor the big number. This rule applies to gas only. What do I mean by that? In the equation, you see the front coefficient number, 2 something, equilibrium becomes 3 something. Now, let's see. In case if I have a high pressure, equilibrium will shift towards the small number. At low pressure, equilibrium will shift towards the big number. Remember, this applies to gas only. So this is the second rule we learned. Now do exercise. First, now count the number. 2 SO2 and 1 O. Equilibrium will become 2 SO3. So the ratio is 3 to 2. 2 plus 1 give 3. The other side, 2. So this is a 3 to 2 ratio. That's how it establishes the number. If you increase pressure, it will favor the small number. equilibrium will shift that way. Next question. What's the ratio? Which arrow will it shift? Next question. What's the ratio? What will happen this time? Nothing changed. Next question. What's the ratio? Which way? Nothing changed. Next question. What's the ratio? Why? 0? Remember, solid not counting. So this is 0, 0, 1. So it's 0 to 1. You decrease pressure, small pressure go on to big number. Next question. What's the ratio? Remember, solid do not count. 3 to 2. So you increase pressure, higher the pressure go on to the small number. That's the way you predict the equilibrium, which way it will shift. The last part, effect of changing in temperature. Student, I hope you still remember year 11, endothermic, how you write, and exothermic, how you write. Let's revise. Endothermic, in the equation, you add heat before the arrow to become something. So you're writing some plus kilojoules. Exothermic, that is you release heat. So something will become something, and the heat release plus the heat after the arrow. So the sign minus kilojoules. That's the way you write exothermic. Please remember this as your background. Now we start Le Chatelier principle. Now endothermic, exothermic. Remember this head rule we early mentioned. Now look onto the top one, endothermic. If this is an endothermic reaction, you add more heat. Which way, according to the head rule, should shift? Will shift towards the product. Now look onto the bottom. If this is an exothermic, you add more heat. Which way will it shift? It will shift in reverse under the head rule on the top picture. So please understand this concept. How about catalysts? Catalysts help increase the rate of reaction. It helps to lower the activation energy. Early we learned at year 11. It increased the rate of reaction. It increased the yield of product. What's mean by increased yield of product? Give you more product. Now we learn equilibrium. Is it the same? It does increase the rate, but it's only to attain equilibrium. What do I mean by that? So Look at this when the equilibrium is reached. When equilibrium is reached, will it give you more black or more white? It will give you just the same, but it will be faster to reach to this stage. So equilibrium doesn't give you more white or more black. It will make it faster to reach to the equilibrium state. That's all. So please understand the difference. Catalysts make reaction faster, so they quicker to reach equilibrium. But catalysts will not increase or decrease the amount of product or reactant. Please understand. Summary. Reactant and product, you increase or decrease under the head rule. Second one, heat, endothermic, exothermic, head rule. The third, high temperature, go high pressure, small number. Low pressure, the big number. Last, catalyst, no effect. Now this is a subsidiary part. The relationship of pressure, volume, and density. This apply to gas only. Volume, density. Year 11 we learned that at opposite relationship. Volume increase, density decrease as follow. Volume increase, density decrease. Volume decrease, density will increase. So you're getting more dense now. Now, how about if we have a pressure applied? If lower the pressure, volume increase, density decrease. So this, you lower the pressure, volume increase, density decrease. If you increase the pressure, volume will decrease, density will increase. So you can see that is the rule. At low pressure, volume down, density up. Pressure high, volume up, density down. Please understand this concept that may help you.